Hello, this is Mr. Win, and this video is over polar graphs. So in the past, we spent a lot of time graphing and sketching things on the rectangular coordinate system. We just plotted basic points, we found symmetry lines, x and y intercepts, asymptotes, periods, even the phase shifts, the A, B, H, K stuff. We're doing the exact same thing now, but for the polar coordinate system. We'll start with point plotting. So here it says graph r equals 4 sine theta. We know sine is periodic from -1 to +1. We can just plug in some nice angles and just see what we get. For example, if you plug in pi over 6, sine of pi over 6 to 1/2. 1/2 times 4 is 2. That's why r is 2 when you plug in pi over 6. As you plug all these points, you get some things we can graph. We'll now graph on this circle. It says starting at 0 for the angle. R is 0, so put a dot at the origin, at the pole. Then go to the angle pi over 6, put a dot at 2, that's right here. Then just go to the angle pi over 3, put a dot at 2 root 3 right here. Go to pi over 2, put a dot at 4, 2 pi over 3, put a dot at 2 root 3, 5 pi over 6 is our angle, put a dot at 2, pi is our angle, put a dot at 0, so we made a full circle. And 7 pi over 6 is over here, but it says -2, so we're going backwards to 2 right here. 3 pi over 2 puts you at -4, 11 pi over 6 puts you at -2, and then 2 pi puts you back at 0. So we did 2 full circles, you could tell. Alright, so notice we plotted them. It appears the graph is a circle of radius 2, whose center is the xy, so rectangular coordinate of 0, 2. So we can confirm this graph by converting the polar equation to rectangular form and then sketching on the regular xy coordinate plane. Or we can use the graphing calculator in polar mode. So let me show you that. If I go to the graphing calculator, turn it on. If you go to mode, this fourth row, go to the third one's polar. If you go to graph, and that says r equals. So the last graph said 4 sine theta. So 4 sine theta. Then I'm going to go over here on the left side, just put a little circle to show us where the graph's going. So that's bold, and here's circle. So notice it'll go in a circle. That's what it's doing. And then it'll go twice, like we did earlier. That's from 0 to 2 pi. Alright. Anyways, next part, symmetry. Notice from 0 to 2 pi, the graph is traced out twice. If we knew it was symmetric with the line pi over 2, we'd have to find less points. We could save time and not have to retrace. Alright, so there's 3 important types of symmetry to consider. We have symmetry with respect to the line theta equals pi over 2, the angle pi over 2. It's up and down line. That's basically like the y-axis. Symmetry with respect to the polar axis, like the x-axis right here, so it flips down here. We have symmetry with respect to the pole, the origin, which reflects over there. Alright, so here's the tests of symmetry for polar coordinates. This is like even odd. So if you place r comma theta with r comma pi minus theta, or use -r comma -theta, and it's the same, you'll get this one. If you plug in this, you get the polar axis. And you plug it in and get this same, that's the pole. Now, the bad thing, or the good thing, well, let's try this. Sketch this polar graph. Try to skip anything. Good. Alright, using symmetry, graph r equals 3 plus 2 cos theta. So if you replace r theta with r negative theta, cosine of a negative angle is the same as cosine of a positive angle. That's because it's even. So we can clear the curve symmetric with respect to the polar axis, the x-axis. Plotting the points on the table using product, we will obtain this shape, and that's a limacon. So you plug in 0. Cosine of 0 is 1. 2 times 1 is 2. 2 plus 3 is 5. That's why 0, 5. And plug this in, you get the same thing. So let me try using calculator for this. Clear that. 3 plus 2 cosine theta. Notice, let me turn that thing back on. Notice it starts right here. It goes in that. Kind of flattens right there. Or actually cuts in and goes there. Alright, so this is called a limacon, like a lime shape. Alright, now so here's the 3 tests of symmetry. They're good, but there's a faster way. Here's the special spiral of Archimedes, it's kind of cool. But if you plug in that stuff, you'll miss things, so we can generalize it and just memorize this important box. Alright, if you know it's some number times sine theta, it's symmetric with respect to the line theta equals pi over 2, that's the y-axis. And if it's some multiplier times cosine theta, you get symmetric with the polar axis, kind of like the x-axis. Alright, because those are the forms. Alright, also zeros and maxes. So two additional aids to graphing polar equations involve knowing the special angle values for where r is the highest, maximum, and where r is 0. So in example 1, we knew the max is 4, which is why there's 4 right there, and then this minimum 0. Right, that occurred at pi over 2, and the other 0 occurred at when the angle was 0. Alright, so we do the same idea here. Graph this, r equals 1 minus 2 cosine theta. So first we know it's a cosine graph, so it's symmetric with the polar axis. Find the maximum value r. So r is 3 when you get pi. So where's cosine the highest? Well, we're subtracting 2 times, we need cosine to be negative 1. So it'll be cosine is negative 1 at pi. Alright, so negative 2 times negative 1 is positive 2. 1 plus 2 is 3. That's why the max is 3. And to find 0, if you said r equals 0, you subtract 1. Then divide negative 2, you get positive 1/2 because cosine theta. You know cosine theta is positive 1/2 at pi over 3. So when you do negative 2 times cosine pi over 3, you get a negative 2 times 1/2 negative 1, 1 minus 1, 0. That's when this actually equals 0. Alright, so here's a table with some values. They graph this. And notice when you have negative values, that's the inner loop of the figure. So here's this other limacon. Let me graph that. 1 minus 2 cos theta. 1 minus 2 cos theta. Here you go. It starts there. Makes this. Just as you zoom, it made a little loop and it went all the way around. Alright, some curves reach their zeros and maximum values more than once. So here's one, r equals 2 cosine of 3 times theta. Alright, so this is a cosine graph. It's symmetric with respect to the polar axis, the x-axis. To find the max, we want this to be equal to r is going to be 2, because cosine 3 theta is going to be 1, right? So to get it 1, we need it to be 0 on the inside, cosine 0 degrees. So that would be a 0, pi, 2 pi, 3 pi with these angles. And if you want this to be 0, you need this to be either pi over 2 or down here 3 pi over 2. So you'd get pi over 2, 3 pi over 2, 5 pi over 2, pi over 6, pi over 2, 5 pi over 6. And you get this. But if you plot these points in specific using symmetry and zeros maximums, you can obtain a graph. Like over here, it's called a rose curve, and each loop is called a petal. And note the entire curve generated as they increase from 0 to pi. So from the beginning, it's positive, so from 0 you go to 2. As you increase the angle, you get a smaller root 2 all the way to 0. Then it becomes negative, so that's why for these positive angles, it's going backwards down here. And it stays negative for a bit until it goes back to 0. Then it goes back positive, then it goes back to 0, then it goes negative, and repeats. So here, notice, I'm going to graph that. R equals 2 cosine of 3 theta. Turn the little tracer tool. Alright, so there's the first petal, second petal, third petal, fourth petal, fifth petal. It's a repeat, remember, it's tracing over because this is 0 to pi. Alright, so there's a lot of special polar graphs. I'll show you all the popular ones. But we use polar graphs because sometimes it's easier to use in this format than rectangular form. So remember that first example was r equals 4 sine theta. If you do rectangular form, that'd be x squared plus y minus 2 all squared equals 4. This looks a lot simpler to deal with and manipulate than this. So really just memorize these. Here are the limacons. When you have r equals a plus or minus some number times cosine or sine of theta, you get these things. You have the inner loop, the cardioid, the dimpled, and the convex. Then we have our rose curves. Rose curves, notice, it's always going to be r equals a number times cosine of some multiplied angle, or sine of multiplied angle. Now, if n is odd, there's n petals. For example, here's n, there's 3 petals. Here, n is 5, there's 5 petals. But if you have 2n petals, if n is even, so you have to double it. So here, n is 4, you double 4, you get there's 8 petals here. Here, n is 2, you double, you get 4 petals here. Alright, then lastly, the circles and lemniscates. Here, the circles is a times cosine of a regular angle or sine of a regular angle. Then for lemniscates, you have r squared. You basically square everything. Alright, so try to memorize those patterns. To sketch a rose curve, here's an example. R equals 3 cosine 2 theta. First, we notice it's a rose curve because it's cosine of 2 theta. Going back to this idea where it's an angle to multiple angles. All right. It has n is 2, so you double that. There's 4 petals. Here's 4 petals. It's symmetric with respect to the polar axis because cosine. Also, this one's with respect to the vertical line. Theta equals pi over 2, and with the pole. To find the max, we want cosine to be 1, cosine whatever angle be 1. So we need this inside be 0, so that's pi over 2, 0, pi, 3 pi over 2. You get 0, you set this equals 0, divide by 3. Where's cosine 0? That's at the top, pi over 2. So we solved that, found pi over 4, 3 pi over 4. So with this information, you could graph it, or you just use a calculator for this. So I think this is one I graphed right. Here, 3 cosine of 2 theta. Let's see what it looks like. Started there, made a loop there, made a petal there, petal at the top. It's going to finish at 4 of them. Alright, last one. Lemniscate, notice this is r squared equals 9 sine 2 theta. If you go back, you can see r squared, a squared, right? And this is a sine where it's diagonal, cosine is when it's sideways. So, sine is going to be diagonal. Lemniscate respect to the pole, the origin. Max value of 3 when sine is, because you want sine to be 1, then r squared equals 9 times 1 is 9. Square both sides, r equals 3. So that's 1 pi over 4 is our angle. From the zeros, you want this to be 0. So sine of whatever angle is 0 at 0 and pi. So that's really pi over 2 if you want pi. It's 0 if you want 0. Then sine 2 theta is negative, has one solution. This left side is always a positive number, r squared. A number squared is going to be positive. So if this is 9, it's positive, this has to be a positive number. So we ignored the when it's negative. So we're going to restrict ourselves to the positive values. So between 0 and pi over 2, and then pi and 3 pi over 2. And let's see, they found some additional points. They plugged in, they got that. So let me try graphing this. R squared, I can't even do r squared. I have to do square, okay. The square roots of 9 times sine of 2 theta. Because we're solving for r and not just r squared. Let's see what this does. There's that. And there's that. Alright, so hopefully you learn how to use calculator and graph. Make sure you memorize the patterns. And that's it. Hope you got any questions. See you soon. Thanks for watching. Bye.